everyone. Welcome to Saturday Afternoon with Iris. I'm Iris Wang. Today we have some special guests, Mr. Newton and his helper Yusi.
Greetings, America, my fellow people. As all of you know, I am Isaac Newton. I have been summoned here today to explain the 3 laws of motion. We shall believe my theory behind the rules. Also, I need to introduce everyone to my fellow helper today, Yusi.
Hello, I'm Yusi. I'm helping out Mr. Newton today with some of his demonstrations.
I don't mean to compliment Mr. Newton. However, he is the person we should all admire. It's our pleasure to have Mr. Newton here this afternoon. Let's get on track. Do you see all the confusing faces in the audience? They're so curious to hear you.
The first law is an object at rest stays at rest, and an object in motion stays in motion, with the same speed in the same direction unless acted upon by an unbalanced force. Objects all have inertia. The resistance of an object has to change in its state of motion. Example of my first law is when a car is pushed by an outside force, a hand. It changes the balance in order for the cart to move. An unbalanced force is when 2 forces act on an object and are not in equal size. This can cause a still object to move, a moving object to speed up or slow down, a moving object to stop or change direction. If it was a balanced force, then the car would be able to move at all.
Wait a second, my teacher didn't tell me that. Now I finally know why Fadio didn't move when I told him to.
That sounds familiar.
Who is Fadio?
That's obviously my car. Oh.
Anyways, my second law is the acceleration of an object depends on the mass of the object and the amount of force applied. For example, it would be harder to lift a couch than a chair.
Go. Example 3. Woo! Lifting a couch. Iris, come help me!
The force equals mass times acceleration.
Okay, I'm sorry to interrupt at this golden time period, but too bad it's my time. Remember, force equals mass times acceleration. Oh, wait, what's happening right now? Wait, is it because the weather today or something?
Also, you might have heard of P equals m times v. This equation calculates how hard it is to stop a moving object. In physics, lowercase p stands for momentum. I talked about mass and velocity already, so let's focus on momentum. Every moving object has momentum because they have mass and are moving.
Mass is a very obvious word, but I still have to tell you this. It's the measure of the density of the atoms in an object. Force, a push or a pull. Well, okay. Acceleration is the rate of change in velocity. Velocity, rate of change in a specific direction. A breeze.
This shows heavier mass has greater force, so it's harder to lift. If you didn't know, force is either a push or a pull. In this example, the force is coming from UC lifting up the chair and the couch.
Please give UC a round of applause. Thank you, UC. Finally, our third law, Mr. Newton.
For every action, there is an equal and opposite reaction. For example, if you're running forward, then your hair blows back.
Physics is awesome!
This happens because there is an unbalanced force.
Thank you, Mr. Newton. Do you guys have any questions? Mr. Newton is the expert of physics. Make sure to contact him if you have any problems on your physics homework.
Ooh, there's a voice coming out of this small little thing. This is magic.
Thank you for watching our show today. I'm Iris Wang. See you next time.